ourselves a little bit about what we did before winter break, okay? A little bit. So let's define a random variable. I've said it before. We talked about it before winter break, but what is it? It's a good question. Hence why I'm posing the question, because I don't think we really know. What if I drew this? Does that give you a little clue? A little bit. What is that thing that I drew up there? Probability, model, distribution, either one would be okay. Good. Let's kind of, I'm going to make some numbers up, okay? Let's just kind of put some numbers in. Maybe. Okay, there we go. I don't know, making something up, okay? What are those numbers? What do they represent? Okay, more in context. Like, what do you mean? What, not just X, what is it? The possible outcomes. Remember we did this before winter break when we talked about games. I think I had a problem where I was a poor teacher and we were like going to have a gambling ring. Remember that whole thing? And there was all the amount, we defined X as being the amount of money that the player won, maybe, I think. I'm trying to remember how we defined it, but I think that's how we defined it. And so we said something like this, that X was the amount of money the player wins. Do you agree? That sounds vaguely familiar to you? And then what is P of X? What is that? The probability of each of those outcomes occurring, okay? And we could make some numbers up. I don't know, a half, a third, 2/3. No, that's not true. It would be a 6, but because they all have to add up to be 1, right? Okay, good. So which of these is the random variable? No, not all of it. There's only one thing up there that's a random variable. It's the X, okay? It's always going to be X. It could be a different variable. It could be Y. It could be something else. But it's what we define it to be, okay? So that would be the random variable in this case. We're going to be today combining random variables, which means we're going to be looking at random variables that have different means and different standard deviations. We might be doubling them, tripling them, playing them twice, that kind of thing, and we'll look at that in a few minutes. And there are a lot of formulas that go along with this that are not on your formula sheet. Sorry. But they are in your book, and they are on page 406, I believe. Let me double check. I opened it up back here at my desk. Yep, page 406. And so as we go through today, I will write the variables down. I'm sorry, the formulas down. But on page 406 are where all the formulas are. Okay. So just kind of as a FYI, you want to make sure you check that out. Okay. So let's start. I'm going to kind of cover up a little bit because I don't want you to look at all of this. I want us to just consider this game. Okay? So this is what we cut almost identically to a situation that we did right before winter break. I know it's been 2 weeks. More like it's been 17 days because it's been 2 full weeks, right? No, that's not true. Just 14 days. No, because it's a weekend added too. So it's 16 days. Friday, because the last time I saw you was last Thursday. It has been 17. It's been 17 since I've last seen you. But we did a problem like this almost identically, okay? So let's read it, and let's see if we can't come up with a probability distribution. So we're going to create the little T-chart just like I just showed you, write all the outcomes and then their respective probabilities. So let's first define the random variable. So read that problem, not the double up points, but before that. What is X? How do we define it? Nope. How many points? Okay, so that's going to be important. And I really do always want you to define that. So this is going to be the number of points that we get. Okay? All right, so we're going to create a little chart. Let's see if you can figure out. It's asking me to find the mean and the standard deviation. So we'll get to do that in a couple of minutes. But we have to create the chart first, don't we? So let's do that. So what are my outcomes? What are all the possible values for x? What do you think? Go ahead. Nope. I agree with the 5. I don't agree with the 3. I agree with 0. Remember, you get no points. So since x is the number of points, I'm going to have 0, because that would be no points. All right, what else can you have? 5 points. And then the last one would be 50 points. Very good. I agree. So those are the only outcomes in this particular game. Do you agree? Okay. So let's make sure that's true, because sometimes we miss one and we have to figure out the missing one. We just can check by checking that all the probabilities add to be 1. So what's the probability of getting 0 points? How'd you get that? I agree that it's half. How'd you get that, though? The even numbers on the dice, aren't they just 2, 4, 6? So 3 out of the 6 outcomes on a dice, or half of the numbers on a dice are even? I agree. All right. How about a 5? How many are 5 points? How many? What's the probability of that? A third, which is the same thing as 2 out of 6, because you have 3 or a 5, 2 of the outcomes out of 6 total, which reduces to a third. Good. And then how about 50 points? 1/6. Okay, good. Do all of them add to be 1? You can check on your calculator. Do you agree? Okay, good. All right, so now we want to find the mean and the standard deviation. Do you remember how to do that? Long ways, if I wanted to do it by hand, the mean would be 0 times a half plus 5 times a third plus 50 times a 6. Remember that? Okay, and the standard deviation, you have to find the mean, subtract it from each value, square it times the probability. Oh, would you rather do it shorthand? Yeah. What's that way? The calculator. So let's go ahead and get our calculators out. All right, so we're going to go to Stat. And then where else from there? So Stat, Edit. All right. Uh-oh. On. Oh, you know what? Hang on. All right, so Stat, Edit, and then I'm going to enter what into list 1? All the random variables, right? All the possible outcomes. So I have 0, 5, and 50. And then in list 2, I'm going to add their respective probabilities. I'm just going to go ahead and add them as fractions. 1/2, 1/3 is 1 divided by 3, and then 1 divided by 6. Okay, good. All right, now what? I'm looking again for the mean and the standard deviation. Stat calc, good. 1 bar stats, because there's only one variable here. What do I have to be careful of on this screen? The frequency list is just where we put the probabilities, and we put them into list 2. Very good. Put those in list 2, and then we'll go ahead and calculate. So I got a mean of 10 and a standard deviation of what? Which number is the standard deviation? That 18.03. Would you agree? Okay. So let's write those down. Maybe. There we go. So I have the mean was 10 and the standard deviation was 18.03. Excellent. So this is all stuff we've done before. Nothing new. What makes it new, or the new stuff is going to be, is what if I posed a question? What if I wanted to double all the points? And I don't want you to recreate the probability distribution. I just want you to use the current mean and the current standard deviation. I don't know any of, let's pretend like I can't see that probability distribution or what's written in blue, but just given this, can I find the new mean and standard deviation? And the answer is yes. So here's what we need to talk about, okay? We're going to be doing several different things with these random variables, okay? We're going to be multiplying them by constants. We're going to be adding constants. We're going to take them and add them together. So there's going to be several different formulas that we need to talk about. So let me highlight some key pieces. If I add or subtract a constant, you're simply going to add that same constant to the mean. Okay? So what I've written in blue there is the word version of this formula I'm about to write. Okay? I'm going to create a formula. So if I add or subtract a constant to the mean, and that's how that's written. I'm sorry, a constant to the random variable. Random variable is x, and I'm either going to add or subtract a constant to it. What is that notation, by the way? E of x, what is that the same thing as? Expected value. What's another name for that? The mean. Okay? The expected value is just the mean. So all I'm saying up here is that it's the expected value, except for I've defined the constant now. I'm sorry, I've defined the random variable to be plus a constant. It's simply just taking the mean and adding or subtracting that constant to it. So that's the formula that you will see in the textbook, and that's all it means. If I have defined my random variable to be add or subtract a constant, the mean is just what you would expect to happen. It's not weird. Okay? What about the variance and standard deviation? Remind me for a minute. The mean is a measure of what? It's an average, but what is it a measure of? Begin to the C? Center, right? Mean is a measure of center. What is the standard deviation a measure of? Spread. Okay, how spread out it is. Now, when we deal with these combining random variables, we are going to have to work with the variances, and I'll explain why in a couple of minutes. But variance and standard deviation have a relationship. The calculator gave me the standard deviation. How could I find the variance? Do you remember? To square it, okay? So we know that the variance of x is just the standard deviation of x squared. Or the square root of the variance is just the standard deviation. Would you agree with that? Either way? We know that. That's their relationship to each other. The calculator will not give us the variance, but we can easily find it. No problem. Okay. What is it a measure of? I said it was spread, correct? Okay. So the spread, when I add or subtract a constant, doesn't change. It stays the same. And we actually talked about this back in September. Do you remember when we lined up around the room with those whiteboards and we had different numbers and I said, okay, everybody add 3 to your number. And what did everybody do? We all moved together, right? Did the spread change at all? When you add or subtract, the whole group just shifted along. So the middle, the measure of center, changed, but the spread did not. Would you agree with that? So that's why it stays the same. That's important. And that's a weird thing, so you have to kind of remember that. That's an unusual thing. Formula-wise, how that's written is this way. Because we're always going to be working with our variances, if I add or subtract a constant, it's just simply the variance. I just don't even worry about the constant at all. Okay? So that's how it's written in formula form. That's how you'll see it in the book. You okay so far? Adding or subtracting a constant. All right. What happens when I multiply by a constant? So we have a different situation here. Let's make it pink. If I multiply by a constant, both the mean and the standard deviation get multiplied by that same value. If I'm working with the variance, which I really want you to always work with the variance, you multiply by the square of the value. Again, that's the word version. What does that mean in terms of the formula? Well, the formula is going to be written this way. If I define my random variable to be some number times, a constant times my random variable, another way to say this is double all the points, it's simply just that number times the expected value. Just what you expect. Nothing unusual, nothing weird. However, the variance of that same random variable is when you take that constant and you square it, and then you multiply times the variance. Okay? So again, that's how you're going to see it written in formula form. Yeah, we're going to look at an example of each one of these in just a couple of minutes. But double all the points would be multiplying by a constant. Yeah, doubling, and that's the example we're going to look at right here. So in this example down here, the key word in this problem is going to be double all the points. There's going to be key words that are going to tell you how to define your random variable. That little phrase, double all the points, tells me that now I'm not just dealing with x. I'm going to redefine it. The number of points is now not just going to be x, but what is it going to be? 2 times x. Does that make sense? Double all the points. I'm just taking the points, which was x originally, and I'm doubling them, multiplying them by 2. Are we okay with that? So what does 2x mean? Well, 2x, because double all the points told me that that's what I was doing. Now I'm going to find the new mean and the new standard deviation. So let's change it. Let's use the expected value. So the expected value of 2x is what? Look at the formula you just wrote down. What do I do with the 2? That's with the variance. With the mean, what do I do? You just take it 2 and you multiply it times the existing mean that was already there. 2 times 10. It's just 20. Didn't we kind of expect that, really? Don't you expect if you double all the points, isn't the mean going to double too? Kind of makes sense. The standard deviation we have to be careful of. Not so much with the constant when you multiply, but when you start adding and subtracting, that's when things get wonky, okay? So I'm going to encourage you to always work with variances, because if you start adding and subtracting, you're going to get wrong answers if you don't, okay? So I'm going to ask that we do that. So we have to find the variance. What is the variance of my original x? How would I find that? I would take 18.03 and do what with it? Square it. Not square root it, square it. Okay? This variance is a standard deviation squared. So what number is that? What is 18.03 squared? What, 325.08? That sounds right to me. Okay. Variance will always be bigger than your standard deviations. It's kind of a way for you to check yourself to make sure you went in the right order. So I want to find the variance after I double all my points. And then I'll work backwards and get my standard deviation in a minute. What do I do with the 2 now? This is where you square it. I take 2 squared, and I multiply it times the existing variance. I'll go ahead and write variance of x. We know what that is because we just found it, and that was 325.08. So what is the variance of my newly defined random variable after I've doubled all the points? If I take that and I multiply it times 2 squared, I should get, that's not right. Oh, you rounded differently. That's okay. If I did it, I would accept that. Obviously, it's more accurate. 1,300 and something, would you agree? Was it 1,300 and what? 0.32? Depending on how you rounded your original answer, it'll be a little bit different, but that's okay. It'll be close. It should be close to 1,300, okay? To what? 0.032, okay. And if you just said 1,300, it wouldn't be wrong, Okay? It's still asking me for the standard deviation, though. So how do I find the standard deviation of my random variable? Square root. This is where I square root. The square root of 1300.32. And what is that? $86.06 or 36.06? That sounds about right to me. Okay. So if you are given an existing mean and standard deviation, and I have redefined my random variable, I can use formulas to come up with new means and standard deviations. So we know what to do if we multiply by a constant. That's what happens here. We'll also look at adding and subtracting in a few minutes. Okay? Any questions so far? We good? All right. We need to add, we need to add some more to our formula page because there are a few more. So let me add the, well, you know what I'll do? I'll add them as we go through because they'll be here. Okay? So here's where we're going to combine different random variables together. If you add or subtract 2, the mean is just the sum or the difference. Okay? Just honestly, the mean is what you expect it to be. It's not anything unusual. In other words, if your newly defined random variable is 2 of them added together, it's simply just going to be the mean of x plus or minus the mean of y. Nothing, I mean, it's just what you expect. Okay? Nothing weird, nothing unusual. So that's highlighted in yellow is the word explanation. The blue is the formula explanation. Okay? The variances are the ones that mess you up. Okay? So you have to be careful a little bit with that. So if you look at the next bulleted point, it says if you add or subtract 2 independent random variables, the variances is always the sum. It's never the difference. Okay? So that's kind of important. It's always the sum. Let me show you what that looks like in formula form. The variance, if I define my random variable as x plus y or x minus y, it doesn't matter. It's always going to be the variance of x plus the variance of y. You never subtract variances. Okay? So it's kind of the unusual thing. Okay, even if you define the random variable as a subtraction, we're still going to add. Yes, ma'am. Independent just means that one will not affect the other in this case. So I play the game twice. The outcome of my first game doesn't affect the outcome of my second game. Or you play the game and I play the game.
Yeah, and then it says then the variance is the sum, but what if it was dependent?
Well, then it's a different situation. Because then the probabilities are dependent, and then it's not something we can deal with. We will assume, the assumption is that they will always be independent. Okay? It's a good question. All right. So let's, taking this new information down, let's look at the same situation. The same dice game that we just played, a mean of 10, a standard deviation of 18 point something. What are the new mean and standard deviation if I play the game twice? How do I define that random variable? What does play the game twice mean? What is x if I play what is x if I play twice? I don't want to do line. I want to do highlighter. Here we go. If I play twice, what does that mean? What does play twice interpret? 2x? Is it the same way as double all the points? No. Be very careful. And this is what's weird, because since pre-algebra, you have been taught that x plus x is the same thing as 2x. Guess what? Not in statistics. Okay, play twice in our case means you played it once and you played it again. That's what play twice means. You've done it 2 times. It is not the same thing as 2x. 2x was like double the points. Okay? You've taken your random variable, each of the outcomes, and have done something to it, to those outcomes specifically. Here, I'm taking the same outcomes, and then taking the same outcomes again. Why does that matter? Matters with the variances. I'll explain that in a minute. All right, so, got a question? Oh, I thought you were, I guess you should raise your hand. So how do I do this? How do I find the new expected value? What do I do? What was the expected value originally? 10, okay. So what does it say if I add to, look at the very top there, what am I going to do with the 10s? 10 plus 10, right? That's all you're going to do. It's going to be the expected value of x plus the expected value of x again. Again, it's not unusual. It's not any different than you think. Same mean, by the way, is double the points. Don't you agree? So it wasn't the mean that was weird, but your variances will be different. So how do I find the variance? First of all, if I did just the standard deviations, what would the standard deviation of x plus x be? What do you think it's going to be? If I just dealt with, if I didn't worry about variances at all, and I just said standard deviation, if I added the two, wouldn't it just be 18 plus 18? 36? Keep that number in the back of your head, and I'm going to show you why you can't do that. Variance of x plus x. Just the variance of x, which was what, 365? No, what was it? Maddie, you need to put your head up, baby. 325, sorry. 325.08 plus 325.08. All right, what is that? Okay, so 650.16, good. And then how do I find the standard deviation? What do I have to do with it? Square root it, good. 650.16. What's the square root of 650.16? 25 point, I'm sorry? 0.5, okay. Is that what you expected? Remember what you said? If I just took the standard deviations and 18 plus 18, what'd you get? Wasn't that 36? But if you do it with the variances, you get 25. Much different. Okay? So it's really important that you always work with the variances. It has to do with the fact that you can't take the sum of a square root. It has to do with this. The square root of 4 plus 9 is not the same thing as the square root of 4 plus the square root of 9. That's why, that's the algebraic reason why you can't do that. Okay? Because isn't this the square root of 13? And isn't this just 5 different numbers? Okay? So you have to be careful. All right. So I'm going to pause the recording and I want you to try the next one. Okay? You and your friend both play. What's the difference in your earnings? You want the mean and the standard deviation of the difference. Okay? So I'm going to pause this. I want you to redefine the random variable. We know that it means, or the key word is difference in your earnings or winnings. Redefine it and find the new mean and standard deviation. You can't do it without defining the random variable first. So what is that? X minus y, because it's you and your friend. It doesn't matter if you say x minus x, by the way, because it's the same mean and standard deviation, so it really doesn't matter. But it's the difference, so you're defining it as a subtraction, okay? So go ahead, using that information, try to find the mean and the standard deviation. So the mean is what you expect. Again, we have redefined our random variable as x minus y. X minus x, They're the I mean, it's just the same, it's me and my friend play. It'd be me playing twice, but you're just with a difference in your earnings, right? So that's why it's subtraction. I'll call it Y just so it has it's you and your friend, that's fine. So the expected value for this is just going to be what? It's the expected value of me minus the expected value of my friend. So it's just 0. Would you agree? Do we expect that? Does that make sense? It's kind of weird, but it's true, right? What about the variances, though? The variance is not 0. Matter of fact, I'll tell you, I know that the standard deviation is 25.5. Because you can't subtract variances. So the variance of x minus y is the same thing as the variance of x plus the variance of y. Remember, you can't subtract variances. So even though your random variable is defined that way, when we're talking about spread, you don't make your spread negative. You want to think about it that way. Spread always has to be a positive number. So you can't subtract them. You always have to, like you're inverted, I don't know, something strange, right? It doesn't make sense. Your spread has to be a positive number. Okay, so isn't that just, what was it, 325.08? When we did this already, we did it right above it, didn't we? It's the same thing as what you had above. So the standard deviation of x minus y is just the square root of this. Which is what we got. Okay? So, yes, Cameron. Yes. Yeah, yes, that's true. Most often, you're going to be given different values if it's required. That's why I hesitated to call this a y, because it had the same mean and standard deviation. Okay? It really is x minus x. Okay? How are you feeling so far? The hardest part of this is making sure that you can read the context and define the random variable the way it's asking to. Is it 2 times x? Is it x plus x? Is it x minus x? How am I defining that? That's really the hardest part. But let's look at an example here where we're going to be comparing. Okay, and so this is going to be kind of like our last contextual situation that you're going to do, we'll do together, and then you'll do some on your own. Okay? So read this to yourself for just a second. Let's see if we can put meaning to this. So I have 2 different schemes. Okay? We're trying to figure out which one we want to go with, which one has a better mean, which one has a better standard deviation. But I have to define the random variable first. What's x in this case? It's the what? Number of gallons. Very good. And it actually says that up here, doesn't it? It says x is the number of gallons of propane or whatever. All right, so let's take our 2 schemes and redefine our random variable. How am I going to define using x, scheme 1? What does the 2 have to do with it? Per gallon means every gallon you're charging $2. So how do I define that random variable? I'm taking each outcome and multiplying it by 2. So what is that going to be? 2x. That's my random variable for scheme 1. What's my random variable for scheme 2? Somebody besides Cameron. Perfect. 1.8x, because it's that much per gallon. And then we have a $50 service charge just for walking in the door. He's going to charge you $50. Delivers you no propane. He just shows up. That's nice. That doesn't seem fair. but the rate's cheaper. We actually did problems like this. Well, we didn't together, but your Algebra 1 teacher did problems like this with you. If you remember, isn't this a slope of 2, a slope of 1.8, and you had two different slopes, and you looked where they met, and you decided at what was my break-even point? Does that sound familiar from a while ago? Okay, same kind of idea. Okay, we have two different situations, but in statistics, we're more concerned for the statistics, the mean and the standard deviation, and looking at it from that perspective about which one do I want to go with for here. So we're going to do two different things. We're going to do scheme 1 and scheme 2, and we're going to find the new mean and standard deviation. Because we're given the standard deviation of 42, and you're given the mean of 318. So you're given some information for just plain old x. Now that we've defined them differently, can you find the new ones? Okay? How do I find the expected value for scheme 1? What am I going to do? What did I do before? I find the mean. The mean's not the unusual one. What did I do before? What do I do with the 2? Yeah, so I just take the 318 and multiply it times 2. I agree. And what is that? Jennifer, would you find that for me? 318 times 2? The calculator's fine. I tend to use parentheses so it doesn't look like a decimal point. Thank you. So 636, that's dollars, that's an average. So on average, if you use scheme 1, you're going to be charged $636 on average. Okay, that's fine. How do I find a standard deviation of scheme 1? What do I need to work with? The variance, but I'm not given the variance. What do I have to do? All right, so let's come up here. I think that's always a good idea. If you're not given one of the statistics that you need, find it. How do I find it? 42 squared. Sure. What is that? 1,764? Agreed. All right, so what do I do with the 2 in my newly defined random variable? Square it. So it's 2 squared times 1,764. It's going to be a big number. Oh, you deleted it. Never mind. $7,056. And then I'm still not done because I have to find the standard deviation. So what should I do? Square root. Good. I think it's just 84. Okay. All right. That makes sense. That's good. How about scheme 2? So I'm going to pause the recording. I'd like for you guys to try scheme 2. Same thing, using the newly defined random variable that we have here, which means the variable, it's 1.8x plus 50. We're going to use that. I want you to find the new mean and standard deviation. So I'm going to pause the recording and have you guys try. It looks like most of us have had at least a chance to attempt this problem on their own. Most of us got the expected value correct. The expected value of my newly defined random variable is just what I expect it to be. I take the 1.8, I multiply it times the mean of 318, and I add 50. It's really nothing that you wanted. 622.4? Okay. So Byron, you want to tell me how to do the next part? Go ahead. Okay? So I have to work with the variance, right? Okay? So the variance of 1.8x plus 50, what do I do from here? Right, I don't add the 50, but what did he forget to do? Square the 1.8. I agree. Okay? Right, you got to square the constant that you multiplied by, but you're right, we don't add the 50, okay? Because when you add or subtract a number to a distribution, it doesn't change the spread, okay? And so, what did I get here? Thank you. 0.36. Thanks, Josh. All right, and now I'm looking for the standard deviation, and the standard deviation of 1.8x plus 50 is just the square root of that number. I believe you got 75.6. That sounds right. Okay. So you really do have to be careful that you're really using the formulas. Okay. So depending on how your random variable is defined, sometimes you have to always add the variances. You never add constants to variances. So you have to kind of be a little careful there. Okay. Any questions? April, we good? Okay. Awesome. All right, the last thing I wanted to show you was a problem like you're going to see on your homework. And it has no context, so it's kind of weird. It's going to look like, hang on, this one. Okay? So you're going to have two problems on your homework that are going to look almost identical to this. There's no context. There's no number of points. We're not looking at the number of gallons of propane. There's no context behind it. You're just given a random variable x, a random variable y, and the respective mean and standard deviations. I'm going to have us try a different one here. I'm going to make this 2x minus y, and I'd like us to do just that one here, okay? Because I'm going to have us look at some problems from the book and make sure we can define them correctly. So if I have given you that is my new random variable, 2x minus y, how do I find the mean? Let's start with that, and then we'll do the variance, or the standard deviation. How do I find the mean of this? Tell me what I plug in. 2 times 40 minus 60. Perfect. Just taking the mean from both x and y. The given information. Really nothing to it. Plugging and chugging. What do you get, 20? Perfect. If I want to find the standard deviation, I really have to work with what first again? The variance, okay. So tell me how I do that. Okay, so I have to find the variances of x and y first. Would you agree? I actually think that we should do that always. So if I want to find the variance, kind of do it up at the top. Do it before you even begin the problem. 12 squared, because it's the standard deviation squared, should be 144. And the variance of y is 16 squared, which is 256. Good. Okay, so that's definitely a needed step. But how do I come back and do this? Tell me what numbers I'm writing down. It's a constant, right? So it's going to be what with that constant? Square it. So 2 squared times 144, because it's the variance of x. Then I have 2x minus y. So what's next? Plus. Why plus? Because you never subtract variances, right? It's always plus, no matter how the variable is defined. Okay? And then it's going to be what? Plus 256. Very good. Okay? Tell me where the number is. Even? 832? Oh, there's no decimals, so that makes sense. All right, so I've got to find the standard deviation of 2x minus y. This is the square root of 832. And what do I get? That sounds about right. Okay. Good. So in some some of your homework, you're going to have problems like this. I don't think these are the hard ones because you're given the random variables already defined for you. It's just using the formulas, right? I'd like to look at some of the problems from your homework where you have a contextual situation like this where you have to figure out how to define the variable. Can we do that? So I'm going to tell you what your homework is. I'll give you all the problems, and then we're going to look at the ones that have the word problem ones and make sure we can define them one by one, okay? So your homework is going to be Chapter 15, problems 30 and 32, and these are the first two are the ones that are easy, like the ones we just did, okay? Like there's no context, no word problem to it, just using the formulas. Then we get into some context. Okay, so those are the problems. I'm going to go ahead and stop the recording at this point, and we'll go from there.